Okay guys, welcome back to grade 9 science in the optics unit. Today we are going to be taking up some of the homework that we've done recently, most importantly, the Explore Learning Gizmo for ray tracing diagrams for converging and diverging lenses. So I will share my screen with you guys now so that we can take a look at the planner for today. The planner for today, reviewing the Gizmo, and then getting you guys started on the converging lenses ed puzzle, as well as worksheet 7 for some practice with converging lenses. So before we begin with that, let's take a look at the ray diagrams lab simulation that we did online last class. So the Gizmo starts with some prior knowledge questions, just trying to activate or get your minds on the activity. Question number 1 asks you to draw the rays as they would converge in order to start a fire in the dry grass here. So again, the key word here is converging, right? Agnes is trapped on a desert island with nothing but a magnifying glass. So a magnifying glass, we know in this optics unit, means that it's going to be a converging or convex lens. Anytime we see the word magnifying glass, we know that means that it's converging, okay? So a converging lens in this case, I'm just going to try and annotate here. A magnifying glass, oh, that's not going to work, is it? Too bad. Hold on. Spotlight. I'm trying to get used to these annotation tools here. Oh, that's not going to work either. Okay, I temporarily quit because I don't want to waste your time, but I'll work on the annotations in a minute. So the magnifying glass we know is a converging lens, which means that these rays are going to come together, right? That's what converging means, is that they're going to come together at one point. So question 2 asks, hey, a magnifying glass is an example of a convex lens. Why is a convex lens used? The answer that I'm looking for is because convex, remember we talked about convex with the V, the rays will converge. Whereas if we have a concave with a C, they will diverge, where C and D are close in the alphabet and V and V are the same letters, so they pair up together. So convex, converge, and concave and diverge, okay? Just a useful little anecdote for you guys to remember the difference between the two. So the reason why this is going to start a fire is because we're concentrating the energy from these electromagnetic waves that we are in light form, the light rays, these electromagnetic waves, when they converge onto a single point, all of their energy, because electromagnetic waves all have energy, all of that energy is being concentrated onto one spot. Okay, so that's why it's useful for starting a fire. Any questions about those prior learning kind of minds-on activity questions?
No.
No, all good? Awesome. Okay, moving forward, if anybody has a question, please just use the raise hand function, okay? All right, so the Gizmo warm-up gave us a chance to get used to the Gizmo simulator, and it asked us to, using the light rays that are going to refract, set up our experiment using the colorized lines checkbox. So underneath show lines, it also asked us to turn off the central line and the line passing through the focal point, so that the only line you could see is the line parallel to the principal axis. Then we were asked to observe what happens to the line that is parallel to the principal axis after it goes through the lens. And what did we notice? Rule number 1 about a converging lens. Well, we noticed that in a converging convex lens, any incident ray parallel to the principal axis will refract or bend. The word we use in this class is refract to the focal point. That should have been the first rule we noticed. Yeah, Tony.
Could we say it always passes through the virtual focal point since it's on the other side?
So this isn't a mirror. So actually in this case, it's a lens. So it's not a virtual focal point. It's the focal point because it's not virtual. It's not an extension of a reflected ray. It's the actual ray passing through the lens, because we're not dealing with reflection here. We're dealing with refraction. So it's the real focal point. It's actually going through that point, right? Does that make sense?
Yeah. Would we get marks off for that?
You might, yeah. In a normal situation when we did a unit test, if you were to write that it's a virtual focal point, you might lose a half a mark because it's not virtual. It's a real image that we're forming here.
Okay.
Okay, so that's important. That's a great question, Tony. Okay, and then in question number 2, it asks us to turn off that parallel line and add the line through the focal point, and then move the candle. What do you notice about the line? Well, we should have noticed that if it goes through the focal point, it's going to refract parallel to the principal axis, sort of the opposite of what we noticed with number 1. Okay, then the Gizmo asks us to set up our simulation such that the candle is at minus 24 on the central axis, while the focal point is at minus 12. Once we did that, it asked us to run through a number of different simulations. It introduces the idea to us that a convex lens is called a converging lens because it focuses light rays into a point. A real image is always formed when these light rays converge on the other side of the lens. A virtual image is formed when they don't converge to one side on the other side of the lens. Okay? If you place a sheet of paper at the image for a real image, a focused, clear image would be projected onto the paper. So the question is, how do these lenses create images? So it asks you guys to, given the distance at 2f, you place the candle at 2f. So the candle is 12 points away from the focal point, and the focal point is 12 units away from the lens. So what do you notice about the orientation of the candle's image when we have this setup? Well, you should notice that the image is upside down. And what do you notice about the size of the image? You should have noticed that it is the same size when we're at the point 2f. Well, then the simulation asks us to move the candle around a little bit and observe the differences. So what do we notice when we move the candle to the left? We should have noticed that as we move the candle to the left, further away from the focal point and further from the lens, it gets smaller and the image itself moves to the left. Then when we move the candle to the right, the image moves to the right and gets bigger. Okay, then the simulation asks us to adjust the focal point. In adjusting the focal point to the left, the image will move to the right and get bigger. So as we get closer to the focal point with our object, the displayed image on the other side of the lens gets bigger. Whether or not we're moving the candle or the focal point itself, we notice that in both cases, the image gets larger. When we move the focal point away from the object to the right, the image moves to the left and gets smaller. So what's the general theme that we're going to get from that investigation?
The closer the object is to the focal point,
You're off to a good start.
I just gotta open up my.
Large.
Do you want to pass the question on, Leo?
Yeah, I just gotta open my OneNote. Yeah, but pass it on, cause.
Okay, Ilya's got his hand up.
As the distance between the focal point and the candle gets smaller, the image becomes larger, and the other way around too. As the distance gets bigger, the image becomes smaller and moves away from the lens.
Absolutely, absolutely, you are correct. Okay, awesome. So how the image is related to the distance between the candle and the focal point, that's what Ilya just answered. So we're good for question 3, analysis of the simulation that we did in the experiment. So that's question 3 answered. Question 4 asks us to explore and switch the location of the candle and the focal point. So now we've got the focal point on the far left side at minus 24 units and the candle at minus 12. It asks us to shorten the candle so that we can see the whole image and make some observations of what happens. What did we notice that happened there? Well, we should have seen that the image is magnified and located to the left of the candle. So in this case, when the candle is between the focal point of the lens and the lens itself, what we should notice is a virtual image forming because no light rays are actually converging on the other side. So as such, we see a virtual image. Any questions about that so far? Okay, off to a good start. Some further investigation was asked of you. In this case, we needed to return the candle to minus 24 and the focal point to minus 12, and then select a concave lens. So a concave lens curves inward on both sides, exactly the opposite of what we saw with the convex lens. Okay, so we're working with a different lens now. What do you notice when we switch to the concave lens? Did the three lines converge or did they diverge?
Diverge.
They diverged, absolutely. So the three lines spread apart or diverged. This is why it's called a diverging lens. It then asked us to turn on apparent lines. Is the candle of the image a real or virtual image in this case, and explain why. So with our concave lens with diverging rays, do we have a real or virtual image?
Virtual.
Virtual.
Virtual, how do we know?
It's on the same side as the object, and the light isn't focusing on the thing.
Absolutely, Tony, that's a perfect explanation. Good job. Okay, then it asks us to move the candle back and forth. No matter where the candle is placed, what is true about the image? So in the concave mirror, what was always true about the image? Sorry, concave lens.
The image is always between the lens and the focal point.
Okay, what about its orientation?
Up, right?
Yeah, it's always upright. So the image is always upright, virtual, and smaller than the candle itself. Question D asks us finally, what would the observer notice if she looked at the candle through a concave lens? The observer would see an upright virtual image that is smaller than the candle. Question 6 asks us to summarize our findings. What are the differences between the images formed between a convex and concave lens? Well, ideally, I would want you to say that a convex lens can produce both real and virtual images. When it's outside of the focal point, it produces real images. When the object is inside the focal point, it produces a virtual image. It talks a little bit about real images. If you guys could tell me a definition of real images about light rays focusing at an isolated point. Then tell me that concave lenses only produce shrunken virtual images. Those are the general themes from this experiment today. Okay, so are we good with the gizmo, gentlemen?
Yes.
Awesome. Okay, so that was due for homework. Hopefully we've had a chance to get that done. Today's class is going to be about worksheet 7 and converging lens ray diagrams. So there is an ed puzzle that goes over these 3 rules, but we're going to talk about it briefly in class today, just in case if anybody has any questions about the ed puzzle. The ed puzzle, you can use this lesson today, this time to do it now. So your options are to either dial into this lesson and take some notes, or you can exit the Zoom chat now and just watch the ed puzzle and do worksheet 7 on your own. Totally up to you guys. If you want to hang out and ask questions, you guys are more than welcome to do so. If you wanted to head out, you're more than welcome to do so as well. So just like with mirrors, when we are doing ray diagrams for lenses, we have some rules to follow as well. And these ones are also going to be marked out of 5. So we have a total of 5 marks. And remember, the SALT acronym is how we're going to describe the orientation of images.
Leg out.
Sorry? Oh no, am I lagging out, guys?
Yeah.
Okay,
Yeah.
I'm going to ask that everybody stop sharing their video now. Could everyone please stop sharing their videos so that we can try and increase the bandwidth here?
Mr. Gay,
Yeah.
I handed in my video recording for my summit like 2 weeks ago. I
Okay.
just wonder if you've checked it or not.
Late submissions, guys, just send me an email, okay? We'll talk about that privately, all right, Dylan?
All right.
Okay, so just send me an email, Dylan, and we can chat after class if you'd like, all right?
Okay.
Okay, so these 5 marks, where do they come from? Well, we know that we're going to get our 2 marks from our salt, right? A half mark from each. What else do we get marks from? From the mirrors. What else were we getting marks from?
Right lines.
Yeah, the rays. One mark for our rays.
Gator, you're lagging out.
I know. I'm sorry, guys. I've been experiencing some networking issues. Everybody in this town seems to be on the internet right now, so things have slowed down significantly. I'm hoping that the video recording that I post on YouTube will not be laggy. So if it's lagging out, that's okay. I'll post it on YouTube. You guys can head out if you want. I'll continue to go through the lesson and post it on YouTube. This will also all be explained in the Ed puzzle. So I'm going to continue going forward, guys. If it lags out, I'm sorry. It will be posted on YouTube without lag. I do promise you that. Okay? So if everyone could just turn off their video, that would help us out with our bandwidth. So 1 mark for rays, 1 mark for the image itself, and 1 mark for the labels. And the labels we're going to talk about here. So what do I need to label? We need to label the virtual focus, the axis of symmetry, the principal focus, and principal axis. Those are the 4 things we need to label on a lens to get full marks. This is with respect to an image that's located on the left side. So just as with mirrors, determining the image produced is accomplished using 3 simple rules. And these rules and lenses are very similar to the rules that we have with respect to mirrors. So an incident ray that is parallel to the principal axis will refract through the focal point. So if the incident ray is parallel to the principal axis, it is going to reflect through the focal point. That's rule number 1. Rule number 2, an incident ray that passes through the virtual focus of the lens will refract parallel. So it passes through the virtual focus, will refract parallel. And rule number 3, an incident ray that intersects the axis of symmetry and the principal axis. So the axis of symmetry is the middle of the lens, and the principal axis is the horizontal line that's in the middle of our ray diagram. So if it intersects those 2 points, then it will continue to emerge in the same direction without refracting. Those 3 rules, when applied to an image, can be used to locate that image. And that's what we're going to do today. There's a summary image posted here that summarizes all of the different locations, and all of this is discussed in the Ed puzzle. So when we finish our Ed puzzle, we have some practice questions that we can work through here, and these questions will help you gain an understanding of how to locate an image in a converging lens ray diagram. So at this point, you guys are free to go to work on the Ed puzzle in the worksheet. If you have any questions, please stay behind. I know that I have 2 people that have told me they'll be staying behind to ask me a question one-on-one. I will ask that you guys check your chats from me. I do want you guys to be able to send a private message to me throughout the class if you have any questions. So please send a chat if you have any questions. If you've been asked to stay in the private chat, please do so. Just check the chat and see if I've sent you a private message asking you to stay behind. Okay? Everyone else, you are free to go.
Are you marking worksheet 7
Thank
or
you, Gator.
homework?
This is just homework.
So what were you saying is marked out of 5?
On an assessment or a test, those ray diagrams, each of those ray diagrams will be marked out of 5 on a test or assignment in future.
Okay.
Okay?
Thanks.
All right, no worries.
Yeah. Bye, Gator.
Okay, see you guys.
I sent you an email like 2 weeks ago with the attachment of the video on it.
Yep.
So
Did you not see your mark, dude?
no, I think I'm blind.
Oh, your mark's been posted. Are you talking about for the major assignment?
Yeah, the summative.
Yeah, you did pretty well. You got a 3+.
All right.
Okay. Any
Because
questions about that?
it said like if you like send in a video, then it'll improve like tremendously or something.
Oh, okay. So you sent in the follow-up video.
Yeah.
Okay. All right. I made a note here.
Okay. Cool.
Hold on.
Mr. Gate, I submitted mine yesterday. Like when you requested me to send it again.
Yeah, I got that. That's awesome. I think I marked yours, Tio.
Oh, it's not showing up on the screen though.
Oh, it's not. Okay. Hold on. I did get yours, Tio, so I'll take another look at it, okay?
Thanks.
Okay?
All right. Cool. Thank you.
All right?
Yeah, thank you.
See you, Gator.
Okay, see you guys.